Okay, graphing exponential functions. Okay, so let's start with y equals 3 to the x. Okay, so it's an exponential function. So let's make a t-chart here. Okay, so if x is 0, 3 to the power of 0 is 1. If x is 1, 3 to the 1 is 3. If x is 2, 3 squared is 9. If x is 3, then this is a y value of 27. So as you can see, when you do exponential functions, you increase rapidly. Okay? So I'm going to go, here's the 2, 9, 1, 3, 0, 1. Okay, what about these negative values? So if I do -1, anybody know what happens 3 to the -1? It turns into 1 over 3 to the positive 1, so 1/3. So if I do -2, that's 3 to the -2 is 1 over 3 squared, or 1/9. So you can see that I'm getting closer and closer and closer to 0. Okay? We are going to have a horizontal asymptote at y equals 0, and the reason is because this value is never going to be negative. Okay, do you understand why? Obviously, if you do a negative exponent, it just does this, which makes it a smaller fraction. So it's just going to get closer and closer to 0, but it's never going to actually make a negative y value. So when we get closer and closer to 0, it's an asymptote at 0. Okay, and then you can see how rapidly it increases in value. Okay, this point 0, 1, okay, that is an important point because you're always going to have that point. Okay, 0, 1. Because any number to the power of 0 is 1. So you're always going to have that point. And then you're always going to have the point 1, comma, the base. So when x is 1, your y value is going to be whatever the base number is. Okay, so those are important points to kind of think about when you're doing these. Okay, what if I give you a fraction? So y equals 1/2 to the power of x. So this time, let's do a little bit of a chart again. So again, 0, 1/2 to the 0 is 1. So like I said, you always have that point. And then when you have 1, it's always going to be the base. And then if I do 2, 1/2 squared is 1/4. So what's happening is that it's getting lower and lower there. Okay, and eventually, again, you're going to get closer and closer to the height of 0. Okay, so let's take some negative x values. -1, 1/2 to the -1 really means this reciprocal to the 1. So that's 2. -2, okay, means this reciprocal is to the 2, so that's 4. So now it's kind of the opposite idea of what happened in the first one. 3 to the x, as we moved right, it went up. When you have a fraction, as you move left, it's going to move up. Okay, so that's the basics of it. So let's put some transformations on that, of course. So 2 to the x plus 3 subtract 1. Okay, so let's just quickly do a rough sketch of y to the 2x. So you know you're going to have 0, 1, and you're going to have 1, 2, and let's go 2, 4. Okay, now transformations. This is going to move it left 3. Okay, it affects the x. And this is a change into your y, and it's going to go shift down 1. Okay, so I'm going to take this point 0, 1. I'm going to move it left 3. So there, and then down 1. Okay, to get to this next point, I knew I moved 1 over and 1 up. And then when I did this point, it was 2 over and 3 up. Okay, and then remember that you had a horizontal asymptote at 0. So because of that, our asymptote changes. So our asymptote will be at y equals -1. Okay, so that's how transformations happen. Let's actually maybe put our y-intercept on this one. Our y-intercept would be where x is 0. So that's 2 cubed minus 1, which is 7. So that makes sense in our graph, 1, 2, 3, 4, 5, 6, 7, that it would have crossed the y-axis here at 7 as well.